Hi, I'm Mengji from School of Software Engineering at Tongji University. Now I will present my paper towards a systematic approach to graph data modeling, scenario-based design, and experiences. This is the agenda of my presentation. I will present from the following 6 sessions based on my paper. Okay, let's begin. This paper deals with graph database. So, what is graph database? A graph consists of nodes and edges that define the relationship between them. Let me show you an example of a simple graph model. It's a small network of followers in online social networking service like Twitter. It shows the follow relationship between users. Nodes and relationships can hold any number of properties in key value pairs. Recently, graph database is increasingly adopted by data analytic systems. The topic of this paper, graph data modeling, is the process in which a domain problem described as a connected graph of nodes and relationships. However, graph data model cannot come into being by nature. Yes, we do find some guidelines or principles, but we cannot conclude a systematic approach from these works. Besides, current approach missed in considering application requirements. That's exactly the motivation of our work. We aim to propose a systematic graph data modeling approach at a proof of concept stage. Our goal is to match application requirements and facilitate the design of graph-based analytical systems. The primary challenge for doing this is how to analyze the requirements to support graph data modeling. Furthermore, how to translate these requirements to produce a model brings more challenges. In this paper, we used the methodology of scenario-based requirement engineering. Scenarios are representations of real world. During requirements analysis, scenarios can be generalized to models. Here we use domain model to abstract key concepts from scenarios. And furthermore, a set of rules are defined for translating this domain model to produce a graph data model. And this is an overview of our approach. We will go to details later. Now, let's see the related work of graph data modeling. I will give a brief summary of related work. So basically, graph data modeling in industry is designing from scratch. We can summarize some best practices or guidelines from these engineering solutions, but many of them are tied to specific needs. Meanwhile, many research focus on automatic model conversion from relational to graph model or trying to propose some generic graph data modeling approach. But we found that all the above work so far cannot fully support the modeling process from the very start. Our approach tends to concern more about requirements, so it's a requirement-driven approach. Here, we come to the proposed approach. We name it SUMO, referring to graph data modeling using scenarios. This is an overview of SUMO. We can see that this approach has two phases. The first phase is scenario-based domain modeling. First of all, scenarios are collected or created from real world. The scenarios we use might be problem statement scenarios, visioning scenarios, usage or behavior scenarios. Then we extract constraints from scenarios. They are very important to refine our model. Then we will identify domain concepts from scenarios. There are some strategies we use. Discover and invention are used often in object-oriented design, and integration is used to merge those less important concepts into related ones. Split off will split those important attributes to become new entities. Besides, we use operations to identify interrelationships within a domain entity. These operations define the relationships between each object of a concept class. You see, we've adapted domain modeling to be graph-oriented. All these modifications are designed to meet the requirement. And then we come into phase two. Phase two is to transform domain model to a graph model. We set up several rules. Firstly, creating nodes by domain classes. Each object of a domain class will be transformed into a node. Attributes of this object will be properties of the corresponding node. Secondly, extending nodes by generalization. Subclass will be tagged with the type of each superclass. The properties of this node will be extended accordingly. In this way, the information from superclass is retained. And thirdly, generating edges by association. Importantly, multiplicity of associations will be retained in graph model. In this example, every teacher will teach at least 2 students, so in the graph model, there will be at least 2 edges of teach. Fourthly, appending edges by operations. Association describes the relationship between different types of nodes, and for the relationships within one same type of nodes, we use operations to describe. By using the above 4 rules, a domain model is transformed into graph model. And next, I will demonstrate how we use Sumo. There will be a much more detailed example. We applied Sumo to the modeling of a criminal network analysis system. Here we choose a scenario of route checking as an example. The original scenario of route checking is adapted to the following one. It says that Peter and his team want to find out Bob's crime fellows. They mainly lie in those people who take same flight or train or have same route with Bob on the same day or within a few days. So based on the above scenario, we collected the following constraints, such as traveling by flight or by train. There's no difference with them when we talk about traveling route, and date is an important index in route checking. Those constraints will be used to check and refine our domain model. And here, this table shows how we used the strategies to abstract and refine the domain concepts. We can see the date property has been split off to become a node, since date is an important index in that scenario. And here is the domain model we generate. It's different with the general domain model. We identified 2 operations of travel. These operations are used to search travel effectively. And then we map all the elements in the domain model to a graph model. For comparison, we build another graph model which follows a naive approach in which every tuple in relational database will become one node. So in our model, we can see that every person will have a travel chain in time sequence. Multi-step routes are expressed in a certain graph pattern. And then we did a series of experiments to evaluate our approach. We compared the query performance of S model by Sumo and N model by the naive approach. The route checking example will be used in the experiment. We used Neo4j, this graph database, to store our data. And here we grouped 7 sets of queries based on the scenario described before. Each set has 5 different queries. We prepared 4 simple query sets and 3 rather complex sets. And we've written all the queries in Cypher. It's a graph query language provided by Neo4j. For the simple queries, the S model performs consistently better than the N model for all the queries, and significantly outperforming in set 3 and set 4 that concern about travel route. This is due to S model scan less subgraphs than N model, which spend much more time in traversing a large number of nodes or comparing a lot of properties. We can see the model generated by Sumo allows us to perform simple queries multiple times faster. About complex queries, the difference is even bigger. We found that they can hardly be achieved only by Cypher in a model because these queries seek multi-step routes. Generally, we need some offline processing to get them done in relational model. A model is directly mapped from relational model. The difficulty in dealing with these complex queries is similar. But in S model, these queries can be accomplished in normal graph traversals. Then we come to our conclusion part. The main contribution of our paper is a preliminary graph data modeling approach. The experimental results, the case study we've demonstrate are promising regarding Sumo's potential to be used in real development. In the future work, we will consider generating properties of age in model transformation. We will also tend to refine the domain modeling phase by providing scenario templates. Okay, that's all about my paper. If you have any questions, please feel free to contact with me or leave a message here. Thanks a lot.